Okay, so let's take a look at our next concept known as linear functions. Now, I'm not going to insult your intelligence. I know you remember about a linear function, even this slope-intercept form of a linear function. Because when most people say slope, most students go, hey, y equals mx plus b. And that's true, because that's almost the standard form that we use for a linear function. But that's not standard form. This form is known as slope-intercept form. Remember that. This is known as slope-intercept form. As long as the y is by itself, there's two pieces of information you can identify. One is the slope and one is the intercept. Now I'm going to be a little more specific. This should be known as slope y-intercept form, because when it's set up this way with the y by itself, you can easily identify the slope and the y-intercept. So, again, not trying to insult your intelligence. So, the slope is going to be designated by the variable m. Notice the slope is the coefficient of the x, as long as the y is by itself. The y-intercept, remember how you find the y-intercept. You always let x equal 0 when you find the y-intercept. And when x is 0, think about it. M times 0 is 0. 0 plus b is b. That means b would actually be equal to y. That's why the b is always the y-intercept as long as the y is by itself. Now, the standard form looks completely different than the slope y-intercept form. The standard form looks like this. The standard form of a linear equation looks like this. ax plus by equals c. If you're giving this and you want to identify the slope and the y-intercept, then you need to take this standard form and you need to turn it into the slope y-intercept form in order to find the correct slope and y-intercept. Always remember that. Good? Okay, now just as a refresher, there are 4 different types of slopes. We either have a positive slope, we have a negative slope, we actually have the slope equaling 0, and we actually have the slope being undefined. All right, so let's take a look at what these mean. If your slope is positive, that means from left to right on a graph, your graph will be increasing. They say increasing over the domain. And remember, it is going from left to right, because you always go from the smallest x's to the largest x's. With me? Okay. If your slope is less than 0, that means it's negative, which means this will be decreasing over the domain. Again, from left to right. Now, if your slope is actually equal to 0, this is what I call the flat line. This is what I call out in the middle of no man's land, prairie land, with 0 hills to be found, right? This would be your, this would be your horizontal line, because there is no change. There is no change whatsoever. Are you with me? There is no change in your y values at all. That's how come you get the horizontal line. And the last one, the undefined one, this is your vertical line. This is you trying to drive up the side of a building. And that ain't going to work very well. Cool? All right. By the way, one more piece of information before I move on. Slope, if you recall from a previous lecture, slope is also known as the average rate of change. Slope is also known as the average rate of change. Good? Okay, so hang in there. I've got some examples. Okay, so let's look at these examples. The directions say to determine, and they're giving us A, B, C, and D. They want us to determine the slope and y-intercept. They'd like us to graph it. They'd like us to determine the average rate of change, and then they'd like us to determine if this is an increasing, decreasing, or constant function. Are you with me? Okay, so let's look at number 1. Part A says determine the slope and the y-intercept. Well, to determine the slope and the y-intercept, the y value, the y variable I should say, needs to be by itself. So take a look at this function. Is the y variable by itself? Yeah, it is, because remember, f of x is y, correct? When it's a function, the f of x is the y. It replaced it to let us know that this is actually a function. So are we in good order here? Yes, we are. So part A wants to know the slope. What's my slope? Good. It's the 2, because it's right next to the x, isn't it? And the y-intercept, that's remember, yeah, that's right. You let the x equal to 0, and 2 times 0, 0 plus 3, that's the 3. Good. So, got the slope, got the y-intercept. Part B wants us to graph it. Well, we can graph it with these 2 pieces of information we found in Part A. So we need to remember how to do that. So, they only gave us 1 point. And the 1 point they gave us was 0, 3. So here is 0, 3. And I need to find a second point so that I can connect the dots and come up with the line. All right, remember the slope. You should write it as a fraction, 2 over 1. And remember, the top number is your y direction. The bottom number is your x direction. So since this is a positive 2, I'm going up 2 on the y's. This is a positive 1. I'm going 1 to the right for the x's. And when I connect my 2 dots, here is this line. F of x equals 2x plus 3. Cool? So, I guess a little refresher on how to graph linear functions also, right? That's good. Part C. Part C wants the average rate of change. Remember what we said, average rate of change is the same thing as, slope. So AROC, if you remember, this is how I abbreviated in the previous lecture. AROC is, 2. Now, Part D wants to know if it's increasing, decreasing, or constant. Well, take a look at your graph. As you go from left to right, that's right, the graph is increasing. Cool? All right, let's look at example number 2. Same thing they want to know. So, what is your, by the way, is it in the right form? Is the y by itself? Yeah, it is, because that's this g of x. So, that means my slope is, good, -3, because it's right next to the x. Your y-intercept, remember, you let the x be equal to 0. So, -3 times 0 plus 4, good, 4. So, slope, y-intercept, got it. Part B wants you to graph it. Okay, we can graph. And the only point I have is 0, 4. Now remember, the slope should always be written as a fraction. And the top number is the y value, the bottom number is the x value. So according to the top number, I'm supposed to go in the y direction. Yeah, this negative means to go down. So I'm going down 3 spaces. And this x being a positive means I'm going to the right 1 space. So as I connect my dots, this is what my graph looks like. Cool? Good. Part C wants AROC. Well, AROC is the same as slope in a linear function, so nothing, no surprise there, which in this case would just be -3. And Part D wants to know if it's increasing, decreasing, or constant. Well, take a look at your graph. When you go from left to right, because you go from the smallest x's to the largest x's, Yeah, this is decreasing. Good, excellent. Are you guys with me? All right, so one more example. Number 3 over here. Let's see if you're following along. So part A wants your slope. And you're like, I don't see an x. Well, if you don't see an x, that means you don't see a slope, which means it's nothing, right? And for some of you are like, yeah, I ain't buying that nothing. Well, great. Then couldn't I write it as 0x minus 4? Doesn't that still give me a negative 4? Yeah, so what's your slope? Good, 0. How about the y-intercept? Good, you've gotten the hang of it. 0, negative 4, right? I need to graph it. I only have one point, and that's 0, negative 4. Your slope should always be written as that fraction, so 0 over 1. The top number represents the y's, the bottom number represents the x's. So according to the y's, I'm going 0 up, I'm going 0. I'm not going up, I'm not going down, I'm staying here. But according to the x's, I'm going 1 to the right because it's positive. So when I connect the two dots, that's that horizontal line we spoke about, isn't it? Okay. Part C wants a rock. Well, a rock on a linear function is the slope itself, which is 0 in this case. And lastly, part D wants to know if it's increasing, decreasing, or constant. What do you think? Yeah, it's constant because there's no change from the left to the right. This isn't going up, this isn't going down, it's staying constant. Good? Cool, loving it. Okay, hang in there because I got some more examples. Okay, so let's take a look at the next couple of examples. They're asking us if these two sets of data points actually represent a linear function or not. And one way to determine if it does is to find the slope between each point. So I'd have to find the slope between the first two, and then the second and third, and then third and fourth and fifth. Well, you know, that's a lot of work. Because if it is linear, then the slope is exactly the same from one point to the next, correct? The same number up, the same number to the right, same number up, same number to the right, or down, or left, or whatever. You get what I'm saying. All right, so you're like, well, then how do I do this? Here's a very easy way to decide if a set of data points would be considered linear or not. Remember, slope is y over x, isn't it? So, let's look at my y values. Between these two y values, they go down, don't they? From 4 to 1, it goes down. It goes down by how many? Yeah, this is going down by 3, isn't it? Right? Sorry, I want to get this guy out of my way. This is going down by 3 between those two y's. What about number 1 to negative 2? Yeah, that's also going down by how much? By 3 also. How about from negative 2 to negative 5? That's also going down by, good, and from negative 5 to negative 8? Exactly. It's going down by 3 also, isn't it? Okay, now let's look at the x's, all right? And let me fix this x value because I know I made a mistake on that. So, between these first two x values, good, they're going up by 1. Between these two x values, they're also going up by 1, aren't they? Between these two x's, yeah, they're going up by 1, and between these two, they're also going up by 1. So here's what I'm noticing. I'm noticing that my y's are consistent. The difference between every y is down by 3. My x's are consistent. Between every x's, they're all going up by 1. So I have a consistency between what's happening to the y's and what's happening to the x's. Which means in this particular case, since slope is y over x, my y's are going down, which means they are negative by 3. My x's are up, which means they are good, positive by 1, which means in this case it is linear because I have a slope of negative 3. Good? Okay, so once you have the slope, you can actually find the entire linear equation if you need to. And remember, you need slope and you need, that's right, you need the y-intercept. And remember how I mentioned the y-intercept? Yeah, the y-intercept should be written as 0 for x, comma, whatever that b is, right? Well, do you notice here? My x is 0. What's my y? Negative 2, which means you have 0, negative 2 for the y-intercept. Can you write your linear equation? You sure can. You would have, in this case, f of x equaling negative 3x minus 2. Good? Okay, so let's look at this one over here. Same thing. Remember, I wrote it here, f of x and y are the same, which I know you already knew. Let's take a look at what's going on between your x's. Yeah, whoops. Sorry, made a little goof, forgot the negative on that. This is going up by 1, and between these two x's, also up by 1. Between these two x's, yep, up by 1. Between these two x's, up by 1. Cool. Now, let's take a look at our y values. These y values. The first two y values, yeah, they're going up by 5, right? These two y values, they are also going up, but they're going up by 3. These two y's, yeah, they also went up, but they went up by 1. And these two y's went down by 1. The x's are good because they're consistent. Are the y's good? Yeah, no. This one is not linear. This one is linear. Are you guys with me? Okay, cool. Okay, so let's take a look at this example. It says, suppose f of x is equal to 4x minus 1, and g of x is equal to negative 2x plus 5. They've given me 4 questions that they would like to answer knowing these two functions. And to be honest with you, you know how to do these. It's the way they're phrasing them that I need you to get a handle on. So let's take a look at part A. Part A says solve f of x equals 0. Well, here's the deal. Don't you know what f of x is? They told you. They said f of x was equal to 4x minus 1. So instead of writing f of x, couldn't you substitute in 4x minus 1 equals 0? Does that make sense? Awesome. And from here you know how to solve. I'm not going to insult your intelligence. From here you get x equaling to a positive 1/4. Agreed? Okay, let's look at part B. Part B is asking you to solve f of x greater than 0. Well, again, don't you know what f of x is? Yeah, you know f of x is 4x minus 1. So out goes f of x and in goes the 4x minus 1 greater than 0. Cool? And then you solve, don't you? Now, some of you are going, yeah, wait a minute. There's something about when you divide by a number and the sign flipping and all that stuff. Here's the deal. Let me just give you a quick sidetrack. Do you agree that 2 is less than 3? Awesome. If I multiply both sides by a negative 1, then this becomes a negative 2 and a negative 3, don't they? Okay, which one's larger? Yeah, the negative 2 is larger, isn't it? Because when you multiply by a negative, what used to be the smaller number now becomes larger. What used to be the larger now becomes smaller. So the only time the inequality sign flips is when you multiply or divide by a negative number. Got it? All right, but in this particular case, I am dividing by a positive number. So when you divide by a positive, that doesn't change the value. It still remains the same direction. Cool? All right. Let's take a look at part C. Part C says solve f of x equaling to g of x. Well, again, we know f of x is 4x minus 1. We know g of x is negative 2x plus 5, and they're supposed to be equal to each other, right? Okay, so I'm going to let 6x over here, 6 over here. Looks like on part C, x is equal to 1. Good? All right. Last but not least, now I've got the inequality. And they're asking for f of x, which we know is 4x minus 1, less than or equal to g of x. Right? Okay. I'm going to bring my x's over here. Why? I always like my x's to be positive. If they go negative, that's fine. I don't really care. But I get the same answer either way. So in this case, x is less than or equal to 1. Cool? Okay. Hang in there. Okay, so now they're giving me a graph, and they're asking me to solve these 6 questions based on the graph. Are you with me? Now, the one thing they didn't say is exactly what I was solving for. You know, in the last example, I basically set the 2 equations together, or I took one equation equal to 0, or whatever it asked me to do, and I ended up solving for x, didn't I? So now, let's take a look at part A, because this will tell me what I'm actually solving for. Because I need to know if I'm solving for x or y. So, it says f of x equals 50. Now, if I take a look at this, what I'm noticing is that I do not know what x is. Because x is actually written, don't I? Or isn't it, I should say. But this over here stands for the y value. X is not written, so that must mean I need to solve for x when y is equal to 50. So, some of you should write that down for yourself. Solve for x when y equals 50. That's what part A is asking you to do. Does that make sense? So I'm solving for x. So if I take a look at my graph, I know the y is 50. Which of these 3 points has the y being equal to 50? That's correct. This one right here, which means what's your x value? Good. My x value for part A will be 40. When x is 40, y is 50. Good? Let's look at part B. Again, they didn't write the x, so I must be solving for x. And this 0 must be the y value. So, if I know that the y value is 0, which of these 3 points has my y value being 0? Yeah, this one down here, which means the x is equal to negative 40. Cool? Okay, look at part C. Actually, I want to go to part D first, and then I'll go back to part C. Look at part C, or part D, excuse me. Part D says f of x equals 80. So again, I don't know the x, so this must be the y. So if I take a look, this is the point where y is 80, which means in this case, x is equal to 88, isn't it? All right, now let me backtrack to part C. I'm still looking for x, aren't I? And they're asking me to find the x's so that my y is, remember f of x is another y, another way of writing y. Y has to be less than or equal to 80. But since the x isn't written, it's the x's I'm trying to find. What x values are keeping my y's less than or equal to 80? That's the question. Well, here's my 80 for the y's. Now, the x values that are keeping my y's less than or equal to 80 go that way, don't they? They go to the left because this y value is 80. This y value is 50, so it went down, isn't it? It's less than 80, isn't it? And this y value is still less than 80. And this arrow means it keeps going, doesn't it? Okay, so I'm looking for the x's. What x values are keeping my y's smaller than or equal to 80? Hopefully you're like, well, it's all the x's to the left. Good. But remember, when you write them, you always write them from the smallest to the largest. So since this line keeps going, because there's an arrow, that means my x's actually will start at negative infinity, won't they? And they will end at, that's right, they end at 88. And since this says equal to, then that's going to be a bracket on that. So my x's are between negative infinity and 88. Cool? Good. Or, by the way, that's interval notation. Or, set notation says that the x's must be less than or equal to 88 if they want set notation. So we have to be careful what they're asking for. Good? Okay, let's look at letter E. They want f of x greater than 50. Well, for letter E, if f of x is greater than 50, f of x is another way of writing the y, isn't it? So y has to be greater than 50, doesn't it? And I'm looking for the x values that help me keep the y's greater than 50. So if I take a look, here's my y value of 50. What x values keep it greater than 50? Well, yeah, they start here and the y's go up when we go to the right. So they start at 50 and they keep going to, yeah, they keep going out to infinity, don't they? So I could write it from 50 to infinity. But is it equal to? No, it's not, which means you put a parenthesis here. So these are your x's that are keeping the y's greater than 50. Now, mind you, if they don't want interval notation, your set notation would be x being greater than 50. Agreed? Okay. Last but not least, letter F. Now, letter F is quite interesting. They want to know, and these represent the y's again, don't they? They want to know where your y values are between 0 and 80. Well, let's take a look on this graph. My y values are between 0 and 80 from here to here, aren't they? But are they asking for the y's? No, you're solving for x because, again, the x is what's not known. The x is actually written, so I don't know the x. So I need to know the x's that keep this between 0 and 80. So what would those x values be? Yeah, negative 40 to 88, right? From negative 40 to 88. Agreed? Are they equal to? Correct. They're not, so I put parentheses. That's our interval notation. But if they want the set notation, and yeah, these are your x's, remember. If they want the set notation, then your x's are between, that's right, negative 40 and 88. Good? Okay. When you look at a graph, it could be very easy to deal with because everything is visual. Don't make it more challenging than it is visually speaking. What you really need to understand is when they say solve, what are you solving for? Are you solving for x or are you solving for y? Well, if they just write f of x, that means I'm solving for the x because they didn't give me the x value. This number over here is the y value, and as long as I understand that, I know what it is they're asking me to give them for an answer. Cool? Hang in there. Got a couple more examples. Okay, so let's look at some applications of linear functions. The first application reads, the cost, C, in dollars of renting a moving truck for a day is given by this particular function.
where x is actually the number of miles driven. So, and then they ask me parts A through F, and I really don't care about parts A through F yet until I understand what the little blurb is telling me. So, what I'm seeing is this. What I'm seeing is that we have a function, and we've got two variables in the function. We have C and we have X. X is the input, so it is referred to as the number of miles driven. C, or C of X, is actually the output, and that is actually the cost of renting this moving truck for a day. Good? Okay, now, the first question they have is this. They want to know the cost if a person drives a truck 160 miles. So, I am going to scoot us over here. We have C of X is equal to 0.25 X plus 40. Just wanted to make sure I have the numbers correct. And they want to know the cost when the person drives at 160 miles. Well, since X is the number of miles driven, then it would be C of 160. Agreed? Okay. So, yes, I know some of you already have your calculators out, but I always suggest setting it up first, as I am doing, and then punching it into the calculator. And when you punch it in, you get 80. But it's $80. Please make certain you put the correct symbol there so we know it's not in Russian rubles. Good? Okay, let's see what Part B has to tell us. Okay, so let's look at Part B. Part B says if the cost of renting the moving truck is $120, then how many miles did the person actually drive? So, now we have the cost, right? We have the cost itself is $120. And that's going to be equal to this particular function. You know as well as I do, you got to get that 40 out of there. And when you get x by itself, you have 320 miles, don't you? All right. Now, this makes sense because in the previous problem, we had 160 miles driven for $80. This problem is basically telling us that we drove 320 miles for $120. So the cost was more, the number of miles was more than in Part A. So sometimes it's good to do a little double check like that to make sure everything is good. Okay? All right, let's check out Part C. What does Part C want to know? Suppose that a person wants the cost to be no more than $200. They want to know the maximum number of miles the person can drive. All right, so let's take a look at this. They want the cost to be no more than $200, right? Okay, so that means the maximum cost is $200. Agreed? So that means my cost, well, let me write it this way instead. The cost can't be any more than $200, which means the cost must be, that's right, less than or equal to $200. And you're like, are you sure? Well, think about it. If you want to spend at most $50 on a pair of shoes, then that means your shoes are going to cost, right, less than $50 or equal to. So since we know that the cost is equal to 0.025x plus 40, that means that we have, instead of writing cost, we can write this function has to be less than or equal to 200. Cool? Okay, hopefully we're all in agreement. And then, yes, we have to solve, and I'm not going to insult your solving skills. You know as well as I do what you have to do. And yes, I know your calculators are out. So, I have the fact that x has to be less than or equal 640, that's right, miles. Good? Okay. So far so good. let's see part D. Now, D wants to know the implied domain of the cost. And the domain has to deal with the input, right? Okay, so the input is your X value, isn't it? All right, so let's go back and look. The domain is the input. The domain in this case is your X, and that would be the number of miles. Agreed? Okay, so help me out here. Okay, so you can't drive a negative amount of miles, right? So you know you have to start at 0. Now, they could drive 0 miles, which means they're really not going very far, are they? And the problem didn't really tell us how far away they were moving. So here's the deal. Technically, they could drive all the way to infinity if they wanted to. And we could drive, or they could drive 0 miles, which is why you'll have a bracket. So your input is going to be from 0 to infinity. Good? Okay, now let's look at part E. Part E is asking us to interpret the slope, and then part F wants us to actually interpret the y-intercept. So let's come back and let's write down the equation again, or let me say the function again. Now, let's make sure we have our items identified correctly. So, okay, so let's identify our slope. Our slope is 0.025, isn't it? Okay, so here's the deal. I want to kind of do parts E and F at the same time, if you don't mind, because they kind of go hand in hand with each other. So our slope is 0.25. Our y-intercept, and remember, you always put 0 for that x, 0.40. Now here's the deal. Let's look at the y-intercept first. This 0 represents the x, doesn't it? This 40 represents your y. Do you agree? So this is basically telling you that if you drove 0 miles, you're still going to get charged $40. So what that tells me is, for the y-intercept at least, is that it's $40 a day rental. Does that make sense? Because if you drive 0 miles, that's your X value, then your Y value is $40. You're going to get a $40 a day rental charge, is what this tells me. Now, the 0.25, that's being added to the 40, isn't it? So what do you think the 0.025 represents? Yeah, that's the cost per mile. The slope is actually representing the cost per mile. They're getting charged 25 cents a mile on top of the $40 a day rental. Cool? Okay, loving it. Now, let's go on to the next one. This particular problem starts with the function t of x, and they tell you what that is, represents the tax bill T of a single person whose adjusted gross income is X dollars for the incomes between $8,250 and $88,800 inclusive. So, before we start reading A through F, let's identify what's happening here, okay? They give us this particular function, and again, we have two variables, don't we? We have T and we have X. So, according to them, X, which is the input, isn't it? According to them, X is, let's see, X dollars for income, right? That's the number of dollars. That's the income, isn't it? And the T, which is the output, is the tax bill of a single person. Not a married person, a single person. All right. Now that I understand that, now that we understand what the input and the output represent, and we see that function, Now let's get to part A. Part A wants to know the domain of this function. So, remember, in this case, the domain is the input, and the input is being represented by x, yes? And what did we say x represented? X is the income. Well, you know, they told me something about the income. They said it was between $8,250 and $88,800, didn't they? So didn't they, in a way, already give me the domain? Didn't they say $8,250 to $88,800? But then they said the word inclusive, didn't they? Inclusive sounds like they are including, which is why we are putting brackets here. So they actually already gave me the domain. I didn't have to go search for it. Got it? All right, let's look at part B. They would like to know what a single filer's tax bill is if the adjusted gross income is $28,000. So, question, what are they asking for and what did they give us? Yeah, they gave us the gross income they gave us, which according to what we wrote down over here, this is X, isn't it? And they said, what is the single filer's tax bill? So that means we're looking for T, aren't we? All right, so let's get this equation written down. Okay, our adjusted gross income, right? They told us in this case X equals $28,000. And they want to know what our tax bill is going to be for this single person. So that means we're finding the tax bill at $28,000. So when we plug it in, we are going to have to do some work. And yes, I know. Some of you already have your calculators out and you're ready to punch. So be my guest. You guys start punching in for yourself and I'll punch it in for myself. And I know we're probably going to do it two different ways in terms of how we're punching, but so I ended up with $3,787.50 for this tax bill. Hopefully we got the same thing. And here's what I do. I always do order of operations. So I subtracted the two numbers in the parentheses first. I multiplied it by the 0.15, and then I added the 825. And this is what I got. Good? Cool. Hopefully we're agreeing. It sounds like we are. Okay, so part C. What do they want to know with part C? Part C would like to know which variable is independent and which one is dependent. Okay, so we need to remember those words. Independent and dependent. Remember, independent is your input. Dependent is the output because the output depends on what you input. So, in this particular case, your independent variable, your input, is your x, isn't it? Because we even said it in part A. Look at part A. And your dependent is your output, which would be t. Good? Cool. Okay. Looks like we're ready for part D then. Part C wasn't so bad, was it? Part D would actually like you to graph the linear function over the domain. Over the domain. So here's the deal. Let me get a grid system going here. And my domain was all these positive numbers, weren't they? Look at part A. This is my domain. I don't care about the negative end of the world. I'm going to stay in the positive end of the world. And I am going to What's the word I'm looking for? I am going to not have this totally to scale. Yes, I know this is 0. But somewhere over here is 8,250, and somewhere over here is that 88,000. Somewhere over here is this 88,800. So if we take 8,250 and plug it into this particular equation, what do you guys end up with? Good. I end up with 825. Right? So that point is 8,250, 825, because this is going to zero out in the parentheses, won't it? Now, we have to do me personally, I'm only going to plug in the last number, the 88,800, and then into your equation right here, and clearly that's an x value, right? And let's see what we get there. Well, I got $12,907, way up here somewhere. And again, this is clearly not to scale. The $12,907. Oh, remember the 50 cents. Government's going to want their 50 cents. So when I graph it, it's going to look something like that. And it's linear, as well as it should be, because the function that I wrote down in part B is linear. There's no exponent on the x other than a 1. And your y value over here? Well, technically that's also to the first power. Cool? So that's how we make life easy for ourselves. We plugged in the first number of the domain and then the last number, connected our dots, and there we go. Y'all with me? Does this make sense? Okay. There is a part E. They actually want to know what a single filer's adjusted gross income is. If now the tax bill is $3,697.80. So now what are we looking for? Yeah, they gave us the tax bill. They gave us T. They want to know the adjusted gross income. They want to know X. So it looks like we're filling in T in this case. And then finish writing off the rest of the function. And now we got some solving to do, don't we? I agree. Let me get this number written correctly. So there is a couple of different ways you can do it. I am going to just move the 825 over first. And then I am going to divide by that 0.15. And then I'm going to add the 8,250 over. So our individual's gross income, single person of course, is $27,402. Got it? Okay. Last but not least, they want to know the slope, or they want us to interpret the slope. That's part F. Well, in order to interpret the slope, I actually need to know the slope. I don't have the slope. Are you with me? I don't have it. I have got this equation that's written in part D, but I don't have the slope. So I'm going to have to take that equation in part D, and I'm going to have to put it in that y equals mx plus b format in order to find out what the actual coefficient of x is. So let's distribute. And I know your calculators are out. And hopefully we are getting the same numbers as we do our distribution. Okay, so this is the equation I ended up getting. Hopefully we're in agreement. If we're not, I guess we need to go back and punch our numbers in again. And make certain that everything's good. Okay, so they want to know they want us to interpret the slope. So here's the deal. This slope, right? Think about this now. If x is 0, then I get a negative $412.50, don't I? So if x is 0, if the adjusted gross income is 0, then they're going to get paid back, because that's a negative number. They're going to get paid back $412.50. But as x keeps increasing, as this adjusted gross income keeps increasing, then this y value changes. And it will change to a positive number, won't it? As it did in Part B. Does that make sense? So this 0.15 is representing, yeah, hopefully you've got it. This is a 15% increase, because it is positive. This is a 15% increase. This is a 15% of their adjusted gross income is going to get added on every time the taxes are computed. They punch in the adjusted gross income, they take 15% of that, and then tack on this negative number. That's going to tell them their tax bill. So the higher the adjusted gross income, the higher that 15% increase, and then the higher the tax bill. Does that make sense? Okay, cool. Hopefully this makes some sense to you. You have fun with this stuff, and I'll catch you on the flip side.